So, Trig, section 5.1, chapter 5 is the Identities chapter. It may have some infamous, legends about it. It is not the hardest chapter, although maybe for some people it is. But we will learn all of the identities. And this first section is the fundamental identities. You already know the ratio or the quotient identities. Let's see, that's when the tangent of theta equals and the cotangent of theta equals. Let's not fill these in yet. Let's see if we can figure them out. The reciprocal identities, the sine of A, the cosine of A, and the tangent of A. Let's move this back up. The Pythagorean identities, see, something plus something equals 1. 1 plus something equals something else. And something plus 1 equals something too. There are the cofunctions. See if I can squeeze these in. Cofunction identities. Sine of A, the secant of A, and the cosecant of A. Okay, now that I've got all those set up, let's change our color and then see if we can write these in here. So for the ratio, the quotient, the tangent is the quotient of two other trig functions. It is the sine, since they use theta, and the cosine in the denominator of that theta. Now, whatever angle we use here, I used theta here, I used A over here, make sure you use the same angle. The cotangent of theta is a ratio of cosine theta over the sine of theta. The reciprocal is 1 over. Well, 1 over cosecant A is the same as the sine of A. 1 over the secant of A is the same as the cosine A. And 1 over, the only one that makes sense, cotangent A, although they all make sense, it's just sort of nice to have that work out. So the Pythagorean, sine squared, what angle would you like to use? Let's use alpha. Cosine squared, but you better use the same one, alpha. Sine squared plus cosine squared is 1. 1 plus, doesn't matter if we use either tangent or cotangent, we'll do tangent squared. Let's use beta here. For the tangent squared, we must have secant squared and use the same angle, say beta. So if I use the tangent squared here, I've got to use the cotangent squared here of theta, and that means the cosecant squared here of theta. Cofunctions. Sine's cofunction is cosine. The secant's cofunction is cosecant. This should be tangent. Why did I do that? You guys should have told me that. The tangent's cofunction is cotangent. So this is 90 degrees minus A. If you don't like 90 degrees, do pi over 2 minus A. Either one's fine, but make sure if you use 90 that you use 90 degrees, not just 90. So those are the trig identities you already know and have memorized, and you're going to have another quiz on those, but we're going to add 2 more. This is Trig 5.1 continued. There are several more we're going to learn, but these are called the negative angle identities. What is the sign of a negative A? What is the cosine of a negative A? Is going to be important when we start deriving the other identities. So, how do we figure this out? Well, one easy way to look at that, perhaps, is drawing our bullseye. I'm getting better at this a little bit. If I have an angle, call this A, then negative A would be down here. If this point is the point, say, X, Y, whatever that is, now using these same letters, X and Y, what would this point be? Well, it's still X, but now it's negative Y. That would also work for these. If you even were over here, this would be negative X positive Y, but that would be the negative angle would be over in the third quadrant, negative X, negative Y. So these will work. It'll be the same idea. They'll sort of switch like that. So if the sine of A is whatever R is, that's the same R here, is Y over R, what is the sine of a negative A? Well, it's a negative Y over negative or positive R, so it is the opposite. Negative Y over R, which is the opposite of the sine of A, right? And this is the one you will be filling in. What is the cosine? Well, the cosine of is X over R, and the cosine of negative A is also X over R, so it hasn't changed from the cosine of A. And that's what you would fill in for that. It's also good to recognize that the other four trig functions are sort of sisters, in a sense, of these two. For the sine, the other ones that include sine, or the y, is going to be tangent, the cotangent, and the cosecant. All of those include y. Even if they include an x, the x doesn't change. So all of these will change. The only one that won't change is the one that just includes x, the secant. So because secant is 1 over cosine and cosine is positive, it still remains positive here. All of these will have that negative y that will change all theirs to a negative tangent, a negative cotangent, and negative cosecant. Also, these functions are called odd functions, and the cosine and secant are called even functions. We'll look at the next screen to learn more about that. What is an odd function? Well, let's see. An odd function is when what we just saw happens. F of a negative x equals a negative f of x. If that happens for every x, an element of the domain, then this is an odd function. A nice function to think about for this is a function that has an odd exponent, x cubed. This is an example. And if you remember x cubed, it starts down and ends up, but it gets wider and wider. So if you go to f of x, you get a positive value, but negative f of negative x gives you a negative value, but they're the same values. So this has symmetry with respect to the origin. That's odd functions. So what are even functions? Even functions, that's just like the cosine f of x, or f of a negative x equals f of x. It doesn't matter whether you put in a negative. And this has to be true for all x elements of the domain for this function f. Maybe I should have put an f here. Let me pencil this in here too. The example for that uses an even number like 2, y equals x squared. Remember, y equals x squared is just a parabola centered at the origin, opening up. And if you put in an x, you get this value. If you put in a negative x, you get that same value. So that's why it doesn't matter whether it's positive or negative, you get the same value. This has symmetry with respect to the y-axis. Even functions. So, let's do some examples. This is from page 200 in your text. And on, of course, more than just page 200. For number 18, we're supposed to find the sine of theta given, and for number 18, we are given the tangent of theta is equal to negative square root of 7 over 2, and the secant of theta is greater than 0. Now, I want to point out this is exactly, so that when you see that word exactly in the directions, mine especially, that means that we're going to be using square roots of 7, not your calculator's approximation for that. So, how do we find the sine if we're given the tangent? Well, there's lots of ways you can do this. But what I think is best, and it doesn't always follow what the book uses, but if you have your bullseye, draw a picture. Well, I'm not getting in much better. Where is the tangent negative? Tangent is negative in quadrants 2 and 4. It's positive in 1 and 3. Where is the secant? Positive. The secant is positive in quadrants 1, and where the cosine is positive, that's quadrant 4. So, where they're both at is where your angle is at, angle theta. And we can use this reference angle, this is not exactly angle theta, but we can use the reference angle because they just want to find the ratio. We've got this right triangle we can sort of pull out of here. The tangent for angle theta is the opposite over the adjacent. Now, the opposite, because we're in the fourth quadrant, is the one that's negative, and the adjacent is positive. So now we've got things we can figure out, because now we can figure out what r is. So r squared is equal to 2 squared plus a negative square root of 7 squared. R squared is 4 plus 7. R squared is 11. So r is either positive or negative 11. Square root of 11. Well, hold it. R is always positive. So it's positive square root of 11. So if r is square root of 11, and we want the sine of theta, which is the opposite over the hypotenuse, what r is. The opposite of theta is negative square root of 7. The r is square root of 11. Now, if I don't say on a test to rationalize your denominators, you don't have to. Leave it right like that. If you're supposed to, and they probably have, no, this one's not in the back anyway, but if you're supposed to rationalize denominators, then you need to multiply both numerator and denominator by that square root of 11. And now you get, this is a negative square root of 77 over 11. And that's rationalized. That's the sine of theta. So, do you have 4 steps? By golly gee whiz, you do. Now, did you use a trig identity? Sort of. Within this tangent is the sine over cosine, but really it was just back to the definitions. Draw a picture. Figure it out any way you need to. I'm not going to push for this on a test. Be able to figure these out. So, how about another one? How about number 28? Okay. So for 28, the directions say identify the basic trig function. They're going to give you a graph. And tell whether it's even or odd. Now they're giving you a picture of the screen, and I can do the same thing for us. So here's the unknown function. Now I've got this in dot mode. Let's make it connected, but remember this is an older calculator, and let's make it connected. This is an older calculator, and therefore it's going to try to connect things that it shouldn't. So when we graph this, these vertical lines are not there. They are invisible. It's just these sort of parabolic looking things. Now, right in the middle, it may be hard to tell because that looks like another one of your vertical lines that are connected. This is the y-axis. This is the x-axis. They do a better job in the book. So, first of all, which trig function is this? I better go back so you can see it. Which trig function is this? Well, let's see. If you have vertical asymptotes at 0, and these are going by pi over 2s, but you've got another one here at pi and 2 pi, then you should be able to envision, or at least it should, because of the way you draw the graphs, that this started here, went up, back down, went down, and that graph, starting at the origin, is the sine. But this is all the rest of the stuff. So it's really the reciprocal of sine. It's 1 over sine, right? Which is the cosecant of x. Now you can draw a picture that can help explain this. If you need 4 steps, that's one reason I wrote this down, because this is 1 and this is negative 1. And you can dash in the cosine and then say, okay, here's my vertical asymptote, vertical asymptote, vertical asymptote. And this is what I'm seeing on that screen, these parabolic-like things. It's the cosecant. So that's the function. Is this function even or odd? Well, let's see. If it's even, it's got symmetry with respect to the y-axis. So let's continue this back over here. There's a vertical asymptote, and it's got another piece here. Nope, not symmetry with respect to the y-axis, so it's not even. Symmetry with respect to the origin? Yes. So this is an odd function. And you've got 4 steps certainly. Here's an answer, here's a picture to help you figure that out. You've even got 5 if you want to count the 2 lines here. That's number 28. How about number 34? Now here you're supposed to find all 6 trig function values exactly. For number 34, they give you the cosecant of theta is equal to a negative 5/2. And they tell you that theta is in quadrant 3. Well, this is really like what you did before, or what we did before, with number 18. Draw a picture. So, see if I can get better at this. Here's a circle. Not bad. Okay, we're in quadrant 3, so we don't even have to figure out which quadrant we're in. And we've got this angle here, which gives us a triangle. Let's move that triangle out. Make it a little bit bigger. Here's the right triangle. They say that the if the cosecant is r over y, then r is this negative 5? No, that negative goes with the denominator then. So this is a positive 5 because r is always positive. The negative 2 goes with the y. Make sure you get the negatives and positives in the right place. R is always positive. But this is the x. So we know x squared plus a negative 2 squared is equal to 5 squared. We know x squared plus 4 equals 25. We know x squared is equal to 21, so x must be the square root of 21. Now x can be positive or negative. Which should it be? Well, this is in the 3rd quadrant. Both x and y are negative. So negative square root of 21. So if you want to find all 6 trig functions, what is the sine? What is the cosine? What is the tangent? The secant, the cosecant, and the cotangent. Now be careful of this order. I may not ask them in that order, so be careful sometimes. Let's change our colors. So the sine, we can go back up here and say, you know, the sine must be the reciprocal of this stuff. But we can also go to the table. Remember, x is negative square root of 21. And the angle is right here, theta. So the sine is the opposite, negative 2 over the hypotenuse 5. The cosine is the adjacent, negative square root of 21 over the hypotenuse. Negative square root 21, or you can do x over r. Tangent, opposite y over adjacent x. So this is a negative 2 over negative square root of 21. Now, if you're supposed to rationalize the denominator, those negatives cancel, and you're going to have 2 times the square root of 21 over 21. And nothing reduces there. The secant, let's see, the secant is the cosine reciprocal, or it is the r over x. R is 5 over negative square root of 21. And because I've run out of room, I'll let you rationalize that. Cosecant given 5 over negative 2. Cotangent, let's take this form of that tangent without the negatives because they cancel, and put the square root of 21 over 2 because it's the reciprocal of the tangent. So all those things, all those ways of doing that, gives you all these answers. And it's really sort of cool. You're doing this with trig identities and with definitions, everything's coming back. Okay, number 52. Now the directions for these is perform each transformation. That's a step also. Write secant in terms of sine x. Secant x in terms of sine x. Now, this means you just want sine x instead of secant x all the time. And sometimes these, you can do a bunch of different things and still be correct. So if you try to match the back of the book, then it may be a little bit hard. But you should be able to, but it might take some manipulation. Secant is a little bit hard for the basic identities that we know, the fundamental identities. We know, at least to get close, is just to go to cosine, 1 over cosine x. Because secant is really almost always talking about either cosecants with the cofunction identity. But if we want this in sine x, not 90 minus x, we can't use the cofunction. They just want it in terms of sine x. Just this. So, how do we write the cosine? Well, this came, if you're thinking, and sometimes I will add this, you can get steps by telling me what you're thinking. And you're thinking of the reciprocal ID. That's what you're thinking. Now, you might also be saying, you know what? The cosine of square root of x plus the sine square root of x equals 1. Well, this is where we got cosine and sine x involved. But I don't want cosine, so I want to write cosine in terms of sine now. Instead of secant in terms of sine, now I'm doing cosine. So cosine squared x is 1 minus sine squared x. And I don't want cosine squared, so cosine x, the square root, is plus or minus, because I don't know which, the square root of 1 minus sine squared x. And now I've got cosine in terms of sine x. Even though it's squared, it's sine x. So this is perhaps a thought bubble that you were thinking, and now you can write this as 1 over, plus or minus, the square root of 1 minus sine squared x. Check your answers with the back, see if it works, if it's possible. I guess this is 52, so it's not in the back. This is at least one way of writing it, but you can check your answers in the back. Now, with this in mind, we're going to work on verifying identities, because that's the process we're sort of leading up to with all this. Number 66. If we're given 1 minus sine squared negative theta over 1 plus cotangent squared negative theta, and they say that's equal to 1 minus, in square brackets, sine negative theta times sine negative. Oh, I'm sorry. we're supposed to write this in terms of sine and cosine. So I'm sorry, the directions are still different. Write in terms of sine and cosine. So let me put that up here. Write in terms of sine x and without moving that, let's move it back, getting a little close to the edge here. And cosine x. So, one of the things I was doing here is, in the numerator, sine squared x is really sine negative theta times sine negative theta. Over, and you can do the same thing for that, it's 1 plus this cotangent negative theta times cotangent negative theta. Now, the reason I'm doing this is so that I can really get rid of these negative theta things. Let's see, the sine, is that even or odd? Let me put this over here. The sine is an odd function, so you bring the negative out front. So this is 1 minus negative sine theta times negative sine theta over 1 plus, now this is cotangent, not cosine, cotangent. The cotangent is also odd, so it's negative cotangent theta times a negative cotangent theta. All these parentheses just help me keep this straight. Now we've got 1, well, a negative times a negative is a positive, but I'm still subtracting it, sine squared theta, and a negative times a negative is still a positive, 1 plus cotangent squared theta. Now, one of the identities, see, 1 minus sine squared, if you go back to what we did on that previous page, this is the same, 1 minus sine squared, as cosine squared. How did we get that? Well, remember, sine squared theta plus cosine squared theta equals 1. So cosine squared theta is 1 minus sine squared theta. So that's what you're thinking here. The same idea here, 1 plus cotangent squared, but that's, don't have to solve for anything. That's one of the Pythagorean identities without moving things around. That's the cosecant squared theta. But remember, the directions are sine theta and cosine theta. So we got the cosine theta, that's good. How do we get the sine theta here? Well, let's see. Remember that the cosecant is 1 over the sine, and so cosecant squared is 1 over sine squared. So our final answer, when you multiply by the reciprocal, is cosine squared theta times sine squared theta. And you've written that in terms of sine theta and cosine theta. This is going to help you in the next section for verifying identities. But you should be able to do those problems from section 1